Welcome back. Let's look at some solved problems from chapter 10. We're going to do that in two parts. Okay, so for the first problem we have this factory. They operate 2 shifts a day, 5 days a week. During each shift, 400 transmissions. Want to know the capacity. It's very important to keep track of the units of measurement. Okay, so if we have 2 shifts in a day, and we have 5 days in a week, and if we have 400 transmissions per shift, okay, then the quantity is a 2 times 5 times a 400, 10 times 400, so 4,000. But what's the unit of measurement? Well, if we keep track of the dimensions, they should cancel. So days cancel, shifts cancel, and so we're left with transmissions per week. So transmissions per week, if we assume, say, 4 weeks in a month, then we would be looking at, under ideal conditions, 16 transmissions per month. And you can see that on the solved problem. And let's go to the second problem from this first part. In this, it's a solved problem from the chapter on a dental office. The dental office is open 9 hours a day, but they have an hour for lunch, so they effectively operate 8 hours a day, or 480 minutes. And we can see for some number of appointments, and then for each appointment there's both the time that it takes to get ready to do the procedure and the procedural time itself and how many people are scheduled. And so we're assuming if in the problem statement says the dentist is doing all this work himself or herself. So to see what the total time would be in our capacity utilization, if you take that same information, and so now we have the setup times, processing times, and number of patients scheduled. If you look at this formula from formula 10.2, you have a setup time and a processing time, and then number of patients. And each of these rows is one of these subscript i's, so the first, second, third, and so forth. And so if we just take one of these rows as an example of how to compute this total time, we have the setup time S times the number scheduled, and so the 2 times the 15 gives us the 30, and then we have the processing time P times again the number scheduled, and so these two give us 180, and then adding together these 2 times is what gives us the 210. Right, so it's a summation of the setup times plus this. In this case, we're saying each patient requires a setup time, so we're not able to just set up once and then process multiple patients. We have a setup time for each patient, so that's why it's appearing twice. And then this is a processing time times the number processed. So 210 minutes would be what it would take for each patient. If you then do that for each of these rows, then we get that we're using 130 minutes of setup time, 480 minutes of processing time, or 610 minutes total. And if you remember, we were assuming that we had a 480 minute day. Then you can see that we've exceeded that available time by 130 minutes. And for the work that we're doing, if you look at this, about 20% of the time is consumed by doing the setup. And so if we want to be able to improve this, we have a few options. We could look at whether there's some of this work that could be done by someone other than the dentist. we could think about how could we reduce the setup time, or maybe there's a way to improve the processing time. And so you can see those types of suggestions here. We'll continue this in the next video. Thanks.